Hi. Now the speed of a particle is the distance travelled per unit time, and it's measured, for example, in meters per second or kilometers per hour. However, if we have a particle moving round in a circle, then we usually measure the speed that it's going round at by the angle swept out by the radius every second. This is known as the angular speed, often denoted by omega, and is normally measured in radians per second. Now, in this example, the particle has an angular speed of roughly 2 pi radians per second. That's the equivalent of 1 revolution every second. That's because there's 2 pi radians in one complete turn. In this example, I've slowed the particle down. It's now going at pi upon 2 radians per second. That's quarter of a turn every second. Now, if we looked at the speed v as opposed to the angular speed omega that a particle moves at, let's say we've got it moving round this circle then of radius r, where the angle AOB is theta radians. So if the particle moves along this arc at a speed v from A to B, then the distance it would travel would be that arc length, which we should know is r theta. Now, v is the rate of change of distance with respect to time. So, in other words, v is equal to the rate of change, d by dt, of the distance covered, which will be r theta. And since r is a constant, then this is exactly the same as r times d theta by dt. And we tend to call d theta by dt theta dot. So what we've got here is r theta dot. Now, if the angular speed is constant, that is d theta by dt, the rate of change of angle with respect to time, then it's going to be omega. So what we've got then is that if theta dot, the angular speed, is a constant, then theta dot is equal to omega. So what we end up with is the connection between v and omega. It equals r omega, or omega r, it's up to you. Let's just border that off and do try and remember that. Now I've got several examples here that should be quite useful. We'll work our way through them. In the first example, we've got if a particle moves in a circle of radius 3 meters with a speed of 6 meters per second, calculate the angular speed. Well, the angular speed omega is given by v divided by r. So therefore we've got the angular speed omega equals v divided by r. And so for this example, we've got a speed of 6, the radius is 3 meters, so we end up with an answer of 2 radians per second, okay? This next example expressed an angular speed of 40 revolutions per minute in radians per second. Well, we've got to think about the number of radians travelled in 1 minute, okay? So if we put number of radians per minute, okay, what's that going to be? Well, it's going to be equal to 40 times 2 pi. Remember, there's 2 pi radians in one complete turn. And that's going to give us 80 pi radians. So therefore, the angular speed, omega, is going to be equal to the number of radians it goes in 1 minute, which is 80 pi, and then I just need to divide that by 60, the number of seconds in a minute. And if I do that, then you end up with 4/3 pi, okay, radians per second. And I'll just leave it in that exact form. And lastly, we've got a particle here that moves round a circle in 5 seconds at a constant speed of 20 meters per second. Question is, what is the angular speed and the radius of the circle? Well, the angular speed is going to be given from this fact here. It moves round a circle in 5 seconds. So it does one revolution every 5 seconds. That's 2 pi radians for one revolution in 5 seconds. So if I divide 2 pi by 5, it's going to give me that angular speed, which is 0.4 pi radians per second. And as for the radius of the circle, well, the radius is given by v divided by omega. So we have the radius r is equal to v divided by omega, which is going to be v, which is 20 meters per second, divided by the angular speed, which we've now just worked out is 0.4 pi. And if you work that one out, you'll find you come out with 15.91 and so on. So that's going to be a radius, say, of 15.9 meters if we give it to 3 significant figures, 3SF for short. Okay, well, I hope that's given you an idea on how we can use this connection between v and the angular speed and the types of questions that would involve that. Okay?